So cloaking is essentially just an optical illusion, and people have been doing that for hundreds of years. There have been many high-tech approaches to try and achieve cloaking, and the basic idea behind these high-tech or exotic materials is to take light and have it pass around something as if it isn't there. And so we just figured a very simple way of doing that can just be using standard lenses and things that we would normally find in the lab.
What we've tried to develop is a simplified version of a perfect cloaking device for small angles. And what we've done is we've simplified it to a 4-lens system. And as you can see, all we've used are off-the-shelf optics that we can get from any of the optical stores. And the great thing about this is it can be scalable to any size that you can make the lenses. But the most important thing that we've done so far is this is the first device that we know of that can do 3-dimensional, continuous, multi-directional cloaking. So if you have rays that go at different angles, you can have the cloaking device still cloak it while what you see in the background is shifted accordingly without any distortion or changes. Say we place an object, in our case a ruler, in the middle. If we didn't have the lenses, we would be able to see the ruler. But what the lenses do is the lenses actually cloak the ruler. So if you were standing right here and you look straight through, what would happen is the rays would focus and then diverge out. So it actually bends the light around the ruler so that you won't be able to see the ruler if you looked at it straight down. So we have slightly more complicated designs where an object can be cloaked entirely, but we've tried to simplify our design, and what we have is where the light goes through the center of the design, so that cannot be blocked. So the cloaking region is actually a ring-shaped area on the outside rather than the center.
People have been fascinated with cloaking for a very long time, and it's recently been a really popular thing, for example, in science fiction, also in Harry Potter. But I think people are really excited by the prospect of just being invisible.
For scientists, it's also very fascinating because we can actually put math and science behind that to make that a reality. Even though that's been a difficult subject to implement, it's very fascinating scientifically too.
A production of the University of Rochester. Please visit us online and subscribe to our channel for more videos.